Hello, my name is Ed Larson, and this is our presentation for the Fill the Gap boat bumper competition for the OpenWERX challenge this month. And we are Tampa Deep Sea Explorers, Team 1. A little bit about us. We covered this in previous presentations, so I won't go into this too much, but we are a LLC formed in Florida for the purpose of competing in the Shell Ocean Discovery X Prize. And for this OpenWERX challenge, our current team consists of myself, Richard Clark, Chuck Begian, and Ian Blinke. The challenge for this month was to create a gangway and boat bumper to allow the safe transfer of personnel from one boat to another. We were to build a system that allows for safe and balanced transport of the operator from vessel to target, and the passage must be wide enough for a single person. The second goal was to protect the bow area of the boat from damage, particularly the host boat, but also, if capable or if we can, to protect the target vessel as well. And the bumper could not be permanently affixed to the bow. And an additional requirement is that all components have to fit in a storage locker that is 4 feet by 4 feet by 2 feet deep. So our preliminary design for our solution is to build a pyramidal shaped foam cone that is made out of 4-inch thick, high-density neoprene. This is strong, it's light, and it's flexible, which is essential for passing it through small hatchways and into the storage locker. The foam cone, when it is unpacked and assembled, is attached to the bow of the boat simply by one crew member. And it's attached to the boat itself by the tie downs that are located at the to the rear of the bow section. We attach that with 2 ropes. Due to the shape and geometry of the cone, it can be easily slipped over the bow without any danger to personnel slipping or falling overboard. The cone itself is a perfect pyramidal shape that is made from identical foam pieces that are, the neoprene is 4 inches thick as mentioned, but is covered in a tough outer covering, which could be Kevlar, it could be nylon, it could be a high impact plastic, but this allows the pieces to be independently stored, each side stored by itself and then reassembled. The assembly is done with a hinge mechanism between the sides and a hinge pin that is inserted into each of the hinges. The cone itself is strong, light, flexible, and symmetrical, and this will be important to us. As I mentioned earlier, the cone itself is secured to the boat by 2 or more lines that are just essentially ropes or straps that are attached to the outer covering of the cone pieces, and then as the cone is slipped over the bow, these lines are tightened and then attached permanently, or attached by tying them to the cleats at the hard points. Now, one of the requirements for this boat bumper was that it should be able to withstand a 5,000-pound static load, and so we need to do a little bit of math here. I'm not going to go into the equations. I just want to mention what our solutions were. If we apply a 5,000-pound static load to the front of this boat, that static load is distributed due to the symmetry and the shape of the cone. This single force is then equal to approximately 2,000 pounds of static load applied to each face. This, again, the shape and the angles of the pyramid allow this load to be distributed across the surface of each face more or less equally. What we see here is the 5,000 pound load applied to the bow. It translates to approximately 10 pounds per square inch applied across the face of each of our triangular shaped pieces, which is easily sustainable by the boat bow. Further requirement was that the bumper should be able to withstand a 1,000 pound dynamic load impacting the nose or somewhere near the bow once per minute. The dynamic load is also distributed similar to the way the static load was, and dynamic loads of 1,000 pounds become 2,000 pounds per square inch distributed across the surface of the bumper itself. As I mentioned earlier, the cone is composed of 3 high-density neoprene triangles that can be separated and are flexible enough that they can be bent to fit through a 20-inch port or a hatchway, and then they can be stored flat in a 4x4x2 locker. The maximum width here on the base of the cone is 44 inches. Okay, so the gangway, the next portion of the challenge was to design a gangway that could safely transport a single crew member across to another boat. And the solution that we came up with here is an 18-inch wide welded steel or aluminum framework covered with a 1/4-inch steel or aluminum grating that allows it to be light, but is strong enough to support the weight of several men walking across it. It is 40 inches long overall length, and also has a modular design similar to what we were trying to do with the boat bumper. We have a tubular and key slot type of interlock on opposite ends of the gangway. Now what happens here is that there's a keyway designed into the forward section of the gangway and a modified tube at the other end, so that it slips into the keyway at a 90-degree angle, but then once the plank is lowered, what happens is that tube locks in to that keyway, and now they act more or less as a single unit. Multiple gangways can be used to extend the length. I have not done all of the math on this, but you should be able to use at least 3 of these in conjunction. The first one would be used to span the bow of the host boat. The second one would rest on the foam cone as it extends out over the bow section of the boat. As you can see, we have tubular steel rings here, or pipes here, which we can put handrails on one or both sides of the gangway to make passage safer, and in rough seas gives the sailor something to hang on to. These pads are separate from the gangway and can be stored separately. They are 8 inches in diameter, 6 inches in height, which gives us clearance off the deck of about 3 inches of the gangway, so we can clear things like portholes, lines, hoses that might be running around on the deck. Okay, so these are the components all together. Altogether, everything will break down and easily fit in a 24 by 48 by 48 inch space with room to spare. And the way this works, these gangways are 3 inches thick and 40 inches long. So you could store those in this space first, and they would stack up, if you had 3 of them, to 9 inches high. in the space that you have. Then the foam triangles are 44 inches wide and 45 inches long. They're somewhat flexible, but they can lay flat on top of the gangway in the storage space that we have specified here. Then the handrails are 30 inches high, 40 inches, actually 42 inches long, and will fit on top of everything else in the space. And if you've been doing your math, as we've been following along, there's a space at the bottom of this storage space that is at least 1.5 feet or 18 inches wide, and these pads that we need for the gangways, we can store easily 12 of them in that space. So we have room to spare in our locker, and we have a complete solution with boat bumper, gangway, handrails, and pads. Now the gangway needs to be secured to the boat, and for that we have loops at the back of the gangway where we can attach ropes and tie them to the hard points, just like we did with the cone. In summary, the gangway that we've designed is simple, strong, and easily storable. Its modular design allows a variable length. It is more than strong enough to support the weight of a full-grown sailor, fully laden with tools and weapons or whatever he might be carrying. The cone is light, strong, and flexible. Its modular design allows for easy assembly and disassembly and storage. The symmetry of the design efficiently distributes loads across the bow of the boat, and it protects the host boat and the target in the event that a boarding needs to take place.